Hello, hello. Very good morning, sorry, very good afternoon. All the participants, please take your position, take your seat. All the participant delegates are requested to please take your seat. Very good afternoon to one and all present here. On behalf of ISKA and RTM Nagpur University, I, Dr. Smita Acharya, welcome you all in the first plenary session, India 2032, Science and Technology, Challenges and Opportunity. All eminent speaker of plenary session, Vice Chancellor of various university, Director, Dean, Head of the Department, Delegate, I will once again welcome you all in this plenary session. Our today's plenary session are eminent speaker, Professor Ajay Sud Sir, Principal Scientific Advisor to the Government of India and Honorable Prime Minister. I request Banose Sir to please escort Ajay Sud Sir for the dais. Thank you, sir. Now I request Dr. Dhoble, Professor, Department of Physics, to felicitate Dr. Ajay Sud Sir by offering flower. So this is just a presentary remark. Thank you very much, sir. Now I will call Dr. S. Chandrasekhar, Secretary to the Government of India, Department of Science and Technology. I request Bhanose sir to please escort Chandrasekhar sir. Dr. Dhoble sir, please give the pleasantry remark to Dr. Chandrasekhar sir by offering flowers. Thank you, sir. Our third eminent plenary speaker, Dr. M. Ravichandran, Secretary, Ministry of Earth Science, New Delhi. I request Bhanose sir, please escort sir. I request Dhoble sir to please give pleasantry remark by offering bouquet. Our third plenary speaker for this session, Dr. Mrs. N. Kala Selvai. She is the Director General, CSIR and Secretary, DSIR. I request Dr. Dhoble to please give pleasantry remark by offering flowers. Thank you, ma'am. Our fifth plenary speaker of this session is Dr. Alka Sharma. She is Senior Advisor, Scientist, Medical Biotechnology Division, Department of Biotechnology, New Delhi. So I request Dr. Dhoble sir, please give pleasantry remark by offering bouquet. So it's a very unique session for Indian Science Congress 108 as Secretary of all big scientific organization of Government of India are in one dais. So please give a big round of applause to welcome them. Then the convener of this session, Dr. Narayan Rao, He is a Pro Vice Chancellor, SRM University, AP. I request Dr. Dhoble to please give our pleasantry remark to Dr. Narayan Rao. So thank you, sir. Now I request to Narayan Rao to preside the next session.
Chairman of the plenary session and well-known scientist of global repute, Professor Ajay Kumar Sood, Secretary, Minister of Earth Sciences, Secretary, DST, Director General CSIR, Dr. Alka Sharma, our General President present in the audience, Dr. Vijayalakshmi Saxena, and galaxy of scientists present here, members of the Council of Indian Science Congress Association and members of the Executive Committee, faculty members of RTM Nagpur University and other institutions from different parts of the country, young researchers, bright students present here. On behalf of the Indian Science Congress Association, I extend a warm welcome to all of you. You are kindly aware that the plenary session is on science and technology at 2030, India at 2030, science and technology, challenges and opportunities. This session is being chaired by Professor Ajay Kumar Sood, Principal Scientific Advisor to the Government of India. Professor Ajay Kumar Sood, I wish to introduce. Professor Ajay Kumar Sood is the Principal Scientific Advisor to the Government of India from 25th April 2022. He is also the Chairperson of the Prime Minister's Science, Technology and Innovation Advisory Council. Professor Sood is a distinguished Year of Science Professor at the Indian Institute of Science, IISc, Bangalore. He was a member of the Prime Minister's Science, Technology and Innovation Advisory Council from 2018 to March 2022 and also from 2009 to 2014. His research interests include physics of nanosystems and soft matter. He has published more than 500 papers in highly reputed international journals and holds several patents. His work has been recognized by many awards, including the Padma Shri. He has received Shanti Swarup Bhatnagar Prize, the G.D. Birla Award for Scientific Research, the TWAS Prize in Physics, the Millennium Gold Medal of the ISCA, the Sir C.V. Raman Award of the UGC, the Homi Bhabha Award of the Indian National Science Academy, and the G.M. Modi Award for Science and Technology, and the list is very long. These are some of the awards which have been bestowed on Professor Ajay Kumar Sood. Professor Ajay Kumar Sood was president of the prestigious Indian National Science Academy, INSA, and also president of the Indian Academy of Sciences, Bangalore. And he was secretary of the World Academy of Sciences, TWAS, Trieste, Italy. Professor Ajay Kumar Sood was elected to the Fellowship of Royal Society, the most prestigious fellowship in the world, in the year 2015. Let's welcome Professor Ajay Kumar Sood with a big round of applause. Now I request Professor Ajay Kumar Sood to deliver his talk.
Thank you very much, Prasanna Narayan Rao. I apologize for my voice. It is almost fading with time. First of all, let me say it is such an honor and a pleasure to be with you this afternoon. And it's a pleasure to organize this symposium, this plenary session. And I'm very grateful to all the four speakers, distinguished speakers, who have agreed to our request to expose you to all the S&T challenges, opportunities in India. And you will see, you can be very proud of Indian achievement, and I'm sure it will go a long way in really taking this dialogue forward when you think of Indian S&T ecosystem. Mine is not a talk. I was asked to organize this session, but I thought it is like Sutradhar. Sutradhar has to say something. So I just thought before these four brilliant speakers speak for 20 minutes each, I have squeezed 7 minutes for my Sutradhar role. So what I'll do in this few minutes, just give you some idea of where Indian science, technology and innovation system is and how these four sectors which we will cover today are taking it forward. This is not a complete story. You will realize that we have covered a very small fraction of Indian science and technology system. There are many things beyond that, but keeping in mind the time available, and this is what we could accommodate. But this will whet your appetite to know more about these four topics as we go along. So I have just titled this presentation, 7 minutes, Convergence of Technological Revolutions, India Marching Ahead. So I just thought I'll present an fact sheet of STI ecosystem in the country so that you are aware where we stand now and where we should be in 2030, 8 years down, 7 years down the line. So if you look at the R&D intensity, which I have put in various orders, India rank is 75th in a nation of 138 countries, and our global knowledge index is at 44.4, which is slightly less than the global average. So the reason I am giving this data, we have to see as we go along, how do we really raise our STI competence, STI achievements, and then really make forward. Because it's very essential to know the ground realities and what we need to do to really go higher. So in this case, if you look at various separate indices, university education, training, higher education, again I have given the values which are higher than the average on some of them. I will not read out for you, but it means that we still have to go a long way in being really the global leaders in S&T, but we are going in the right direction. This slide tells us that from 2020, the index which I showed in the last slide, and 2022, we already on the positive slope. For example, in knowledge economy index, we are already now from 40.6, we have become 56.1. So you can see there are many sectors where we are very, very positive, and this is what we need to take it forward much, much more. In the commitment to R&D, you will realize that we have retained 0.7% of GDP. But the reason is our GDP is increasing very, very fast. So the blue bars tell you that the GDP has become very high. So even though the R&D expenditure went up, the government continues to do to increase the R&D expenditure. But you have to all, good news is that our GDP itself is growing high and we have to increase proportionally GERD. This is R&D expenditure by sectors. Most of 59% comes from government's amount. So I put that slide to bring into focus that state governments have to increase their R&D funding in order for us to remain competitive and we take our global knowledge index higher. This is a busy slide, I will not go into, but data is interesting that we have, which is a worrying thing for all of us. We have about 255 full-time equivalent per million for 10 lakhs, which is a very small number. For every 10 lakh population, we have only 255 people in the science, technology, engineering and mathematics, and also agriculture and medical included. This number, you can see, is much smaller than many other countries. This has to go up. Without this, you cannot make progress. So the 255 has to increase. For example, in US, it is about 4,300, and for China, it is about 1225. This is again a busy slide, but it only tells you that the annual PhDs in India are increasing. And if you look at the STEM PhDs, we are producing about 40,000 PhDs per year in 2020. This compares with US. It tells, this is what Honorable Prime Minister mentioned, that we were 81 in Global Innovation Index, and now we have come to 40 in just 7 years. This is what he mentioned in the morning, and this is a very good news, but we have to make from 40 to, let's say, within 20 in next 5 to 6 years. Again, I will not go into this. India unicorn surge is happening. We have a huge number of unicorns which have come up. The startup ecosystem has geared up. And this is something which I want to emphasize on every platform. We have to encourage the deep tech startup. We have about 80,000 startups, but the deep tech startups are only 4,000. And if you talk innovative deep tech startup, which is still higher order of innovation, we have only 400 of them in the country. So this is where we need to work. How do we take our deep tech startups to the next level? This is just to tell you that the deep tech startups will grow. Some policy interventions are being thought about, and I am sure it will go a long way. So this is, I will just close my talk, that there are many, many sectors where you will see the S&T progress. Quantum frontiers, as was mentioned by Honorable Prime Minister also, quantum mission is about to be launched under the leadership of Department of Science and Technology. Perhaps Dr. Chandrasekhar will touch upon it. We have advanced communication technologies, 5G and 6G, digital transformation, AR, VR, metaverse, all that will be part of our life in next 5 years. Clean energy revolution is happening. We have green hydrogen, we have battery technologies, many, many things. And the last one, which is my favorite, is the One Health mission, where we are bringing the human health, animal health, and the wildlife health together and addressing all the problems on one platform. So I will just say that these 4 talks which you have today really will capture your imagination in only 4 STI verticals. We have left out many, many more things, but you will have Dr. Ravi Chandran talking about your blue economy, again referred in the morning. We have Dr. Alka Sharma on biomanufacturing, an extremely important field, and they are coming out with a policy very soon. We have Dr. Chandrasekhar on sustainable technologies. and Dr. Kalai Selvi telling us the role of CSIR in this Indian ecosystem. So with this preamble, I close this talk, my presentation, just to say thank you to the organizers, thank you to all of you for being in the hall, and we look forward to a very exciting afternoon. I have requested Professor D. Narayan Rao to introduce all the speakers. As chairperson, I should have done it, but I know any time my voice can fail. So I requested him. So please do the honors of introducing our distinguished speakers. As they say, they don't need introduction. But for the sake of young audience, it is good to say a few words, how accomplished they are, and then we will say. So we will start this session with the presentations by these four people. All right, President Narayan Rao, you want to introduce in which order we are going? Okay, so they have removed my order from here, but Dr. Ravichandran will make us all blue, right? So President Narayan Rao will do the right introduction, and then you will have to speak. Thank you.
Professor Ajay Sood, we are very much thankful to you for setting the tone for the plenary session, India 2030, Science and Technology, Challenges and Opportunities. As Professor Ajay Sood said, this is unique to have four secretaries on the same dais. Indian Science Congress could invite and make it happen. Let's give a big applause to all the distinguished speakers on the dais. Now, I have a great pleasure in introducing Dr. M. Ravichandran. Dr. Ravichandran is the Secretary of Ministry of Earth Sciences, Government of India. Prior to that, Dr. Ravichandran was the Director of National Center for Solar and Ocean Research, Goa. During 2016 to 2021, he worked as atmospheric scientist in Indian Institute of Meteorology, IITM Pune, a center endowed with the responsibility of carrying out research in the different areas of atmospheric sciences. He was ocean technologist at National Institute of Ocean Technology, NIOT Chennai, and a physical oceanographer at Indian National Center for Ocean Information Services in Kois, Hyderabad. His research interests include atmospheric and ocean dynamics, ocean observations, and modeling. He is Vice President of Scientific Committee and Antarctic Research, member of Scientific Steering Group of World Climate Research Program of WMO, the World Meteorological Organization. He is a Fellow of National Academy of Sciences, India FNASC, and a Fellow of Indian Meteorological Society. He has received many awards, including National Award in the field of Ocean Science by the Ministry of Earth Sciences of the Government of India, Dr. Srinivasan Endowment Award by Ocean Society of India, Dr. S.Z. Qasim Award for Excellence in Marine Science, and many, many more. He is editor of the journal Pure and Applied Geophysics. Dr. Ravichandran spent more than 500 days at sea on-board research vessels for various ocean-related studies and published more than 150 papers in highly reputed journals. Sir, now I request Dr. Ravichandran to deliver the talk.
Thank you, Professor Narayana Rao. And first of all, thank the organizer for inviting me to deliver this particular topic on blue economy. And once again, good afternoon to all both on the dais and off the dais. So I will be briefly touching upon blue economy. What is blue economy? And what are the components of blue economy we are envisaging in the next decade? What we want to do in the science and technology realm in the ocean? And also what highly touch upon about the opportunities and challenges in the ocean realm. Of course, the Nagpur is far away from the ocean, but it is the ocean is very important. That's why I need to touch upon the ocean. As you all know that the ocean covers about more than 70% of the Earth's surface, and it provides countless benefits. It feeds us, as well as it regulates weather and climate. If you want to forecast the weather, next few days, you have to depend on the atmosphere because the memory is available in the atmosphere. But if you want to forecast beyond 1 week, then the memory is available in the ocean. Beyond week, it may be seasonal time or interannual time or decadal time or climate scale, you want to forecast or you want to understand, the memory is available in the ocean. So we need to understand the ocean very well. And also you may be knowing that everybody that half of the oxygen, what we are breathing, comes from the ocean phytoplankton. So that's the importance the ocean is having. Of course, it is having a highest carbon sink, both in terms of, especially in the cold water, sink more, and when the ocean has become warmer, then the sinking capability of the ocean is less. And also it provides both living as well as non-living resources. Living, I mean food, maybe fish, seaweeds, and many other aquaculture and other things. And non-living resources in terms of energy, water, and minerals. So all our things are available. Of course, it can be used as for a better tourism as well as the recreation area for the many other areas. And you all know that maritime shipment, 90% of our material transported through ship. So we need, the shipping is very important. The ocean is very important place to transport this material. And of course, it is also security in terms of both the natural as well as the natural disasters as well as man-made disasters. We need to have a protection for that. That is security is very important. Of course, there are about only 5% of the ocean we know. What we know is only in the coastal areas, but we don't know much about the deep oceans. So that is the importance we need to put some effort in understanding the ocean. There are two stressors in the ocean realm. That is, one is the climatic stressors such as warming, sea level rise, and other things, and non-climatic stressors such as over-exploitation of fisheries resources and invasive species, as well as the dumping in the pollution and microplastic and many other waste material in the ocean. So considering this importance of the ocean and its resource available, and internationally, UN has announced the SDG 14. It is a life below the water, wherein the sustainable development goal is life below the water. It has been envisaged. And this decade, maybe 2021 to 2030, it is basically UN has announced the decade of the ocean science for sustainable development. And it is essentially the science we need for the ocean we want in the future. In that connection, the government of India also announced the vision for New India for 2030. In that vision, one of the important paradigm is the blue economy. So just to want to highlight what is the blue economy. Basically, it is a new paradigm, and it is for a higher growth of our GDP from the ocean realm, how we bring it, the scientific knowledge. Maybe basically we want to translate the science to society for the services. How do we translate? And also there are many developmental goals and involving many industries for harnessing energy, aquaculture, and metals, and blue biotechnology, especially marine biotechnology, and also bioprospecting. All these things we need to enhance the present level, from the present level. And of course, the blue economy is indispensable of addressing many of the global challenges, especially food security, climate change, and energy, water, and other things. Basically, we need to harness the ocean resources, but sustainable way, and without degrading the environment. That is the main focus of this blue economy. Of course, in India, we have started thinking of a blue economy policy to bring out. So that's what I want to highlight. What is that we are planning? I think in soon this policy will come out from the government. What is this policy about? Basically, this is all economic activities of the ocean or marine sector. That is what we plan. You know that India is having a more than 7,500 kilometer coastline and is having more, what is called, there are many major and minor ports. As I mentioned, about 95% of the India's trade volume, in terms of volume, is by the sea, and it is having the more than 2.2 million square kilometer of exclusive economic zone to harness the resources, and also there are many fishermen in the Indian coastline. So we need to develop the blue economy, and by exploring as well as optimizing the resources, and we need to develop the technology, and we need to understand the ocean for the harvesting, as well as to maintain the health of the ecosystem. Presently, globally, in all the country, an average 3 to 5% of the GDP, it contributes from blue economy. Of course, in India also, it is in the same level, almost about 4% presently now, and it has to be increased from 4 to 8% by 2030. That is the prime objective of this blue economy policy. So who are all the stakeholders? Of course, it is not the one ministry or anybody can do. So it is having many ministries together, many ministries and departments together, working together. Of course, the Ministry of Earth Sciences is a nodal ministry to coordinate with the various ministries with the different sectors. How do we harness the ocean? That's the main idea, especially fisheries and defense and shipping, Ministry of Shipping, renewable energy sector, as well as environment, commerce, tourism, petroleum and natural gas, of course, the Ministry of Education, and then industrial bodies, and of course, the Ministry of Earth Sciences will lead this. And what are the activities of the blue economy? If you talk about, there are many activities, of course, we are doing here and there, but there are many things, start from fishing, aquaculture, we are doing, but we need to enhance. That is the main objective. You take oil and gas, and the mining resources, energy, water, desalination of water, and we need to develop the manufacturing sector. Though the manufacturing sector is 70% from the land-based, but the ocean-based manufacturing sector, it is not even 1 or 2%. I think we need to increase the manufacturing sector in the coastal area, and of course the construction and the dredging areas, ships and ports, all these things we need to augment. There are various sectors we need to strengthen to harness the ocean. Of course, the knowledge is very important, so we have to improve our science or observation from the ocean side. So this is the main components of the blue economy, which we have envisaged. Maybe it is about the 7 sector. Of course, each 7 components will be dealt by different ministries. The first one is accounting framework, and it will be dealt by the Ministry of Statistics and Planning. And the second one is coastal marine spatial planning, and that will be led by the Ministry of Environment and Forest, and marine living resources by the Department of Fisheries, manufacturing industries by DPIIT and Ministry of Commerce, and logistic and shipping by the Ministry of Shipping, and marine non-living resources by the Ministry of Earth Sciences, and the ocean security and international interface by the National Security Council Secretariat, as well as the Ministry of External Affairs. Of course, the Ministry of Earth Sciences is a nodal ministry to administer all the blue economy policy. I will highlight each one what it means. Of course, in the accounting framework, we need to have what is the ocean wealth is available, both in terms of produced assets as well as non-produced assets. How much is available? What are the things we need to account it? Suppose if you are harvesting fish, up to what level we have to account it? Whether it is fish stock is we have to assess, or it goes to the some of the industries, and from there, how do we account it? So all these things we need to account properly. And also, what are the ocean-related income, and as well as in the welfare from the various groups in the society, especially in the coastal population, what is there available, we need to account it. And basically, we have to have economic production in terms of coastal areas, as well as in the deep ocean, in the mining, desalination, and marine biotechnology, basically in the drugs from the sea. All these things we need to account. So that is the main components of the blue economy. Of course, the size of the blue economy, as I mentioned, it is presently about 4% of our GDP. And the second element is the coastal marine spatial planning. Essentially, it is basically ocean management. What is that ocean management? Basically, it starts from the coastal. How do you manage the coast? Some places we need to develop the infrastructure. Some places we should not develop the infrastructure. We need to understand the ocean and how it will be happening in the various coasts. And then we have to plan accordingly where to invest our infrastructure in the different coasts. Suppose somewhere we want to develop the, what is called some recreation or blue beach, what we need to do. So all these things we need to augment. That is the main important in the coastal marine spatial planning. It is also including the marine protected areas. Basically, what we need to do is protected areas as mangroves, corals, as well as wherever the fish spawning places, we have to identify what is the biodiversity exists, and that biodiversity, where is the resources available, that resources places we need to protect. So this is a globally we have envisaged about 30 by 30. That is means by 30% of the global ocean by 2030 we need to protect. So that is an important activity, not only by India, but there are about 32 countries have signed this agreement, so we need to protect the ocean for the better benefit to the society. Of course, the marine tourism, the countries having big coastline, we are not using the coastal tourism much in India. I think we need to develop the coastal tourism in much bigger way for especially to have the infrastructure in terms of various sports activity, skiing and other things. We need to develop the infrastructures. Thereby, we need to develop entire coast as a tourist spot for attract more than maybe especially the foreign investment and other things. We need to start this place, even include diversity. So when we are not able to utilize this marine tourism, who will do that? It is not possible by any other means. And the third component is marine living resources. Of course, the marine living resources, it is mainly the fisheries. It is in the fisheries about more than 10 million people are dependent on the fisheries and the food security. And also, we have roughly about 6% of the global production is from our Indian fish production, and it is contributing about 1% of the GDP. And if we go by this rate, I think by 2030, we require about 18 million metric ton. But as of now, we have only 11 million metric ton. So we need to go for more harvesting, but we cannot do only in the coastal area. So we need to go for a deep fishing. In India, we don't have a deep sea fishing. It is very meager. So I think we need to encourage the people to go for deep sea fishery for sustainable growth, as well as we need to make a cage culture and seaweed and other ornamental fisheries we need to develop so that our ecosystem will be healthy. And also we need to have, I think in India we don't have a fish which we need to harness in the coming years. Basically, I mean the Blue Revolution is basically to promote the aquaculture, deep sea fishing, cage culture, seaweed, and algae harvesting, and much more than, so that the ecosystem also will be developed and economy also will grow. That's the main objective. And the fourth dimension is basically the marine manufacturing. As I mentioned that the manufacturing in the coastal sector, whether you want to shipbuilding or you want to boat making or you want to net or you have any other fish processing industries or aquaculture tools, it is all the things we are importing. We need to start build up, especially in the coastal area. So we need to build this particular sector. We need to have a manufacturing sector in the coastal areas. And also we need to develop the blue biotechnology, what are the drugs from the sea that we need to harness and channelize. And the similar things, logistic, basically shipping sector, also we need to develop ports and harbor. We need to modernize the things. As you all know that already shipping ministry is going for the Sagarmala with the 4 pillars, basically port modernization and connectivity as well as industrialization and also community, coastal community development. All these things they are doing it. And this will be matured in 2030 with a great effort. And the sixth one is the marine non-living resources. Basically, we need to harness the energy, minerals, and water from our ocean resources. And that is the main thing which we need to do. Apart from our EEZ, there are many other places we have secured some portion in the ocean from the International Seabed Authority. So there also we need to harness the metals and minerals, and we need to develop the technology for harnessing this type of resources. If you talk about the resources in terms of ocean energy itself, there are many energies available, but we need to develop a kind of economically viable technology for harnessing ocean thermal energy or offshore wind energy, or you can take a salinity osmotic power energy wherever the river joins the in the ocean. So the salinity gradient will provide a lot of energy. So we need to develop a technology for harnessing this ocean energy. So these are the various type of technology, some of the technology we developed and some of the things yet to develop, and we need to invest in the development of ocean technology. And the last one is international interface and also the maritime security. We need to collaborate with many other countries as well as we protect the coast, both the natural disasters as well as the man-made any attempt. And in this aspect, we already, Ministry of maybe Government of India has started the Deep Ocean Mission, mainly to develop technology for harnessing the ocean. And also, what are the climate advisory services? Maybe next decade or next few decades, what will be our country coastline? So how it will be changing? So we need to give advisory in that aspect. Also, harnessing the living and non-living resources, what are the technological requirements that also has been envisaged in the Deep Ocean Mission. So coming to the end, I think ocean is having oceans of opportunity and challenges. So both in terms of resources, we have a lot of living as well as non-living resources are available. We need to develop a technology. We need to understand the ocean better so that we can sustainably, environmental friendly utilize this. However, we need to have some of the challenges like develop a technology, and we need to sustainably utilize, and we need to eco-tourism and clean energy, we have to be in place, and we need to protect our coastal and also the marine pollution and litter we have to regulate, and international cooperation and security, and finally we need to build a capacity in the ocean sciences. So these are some of the challenges and the opportunities in the ocean sector. Thank you very much for your kind attention.
Before Professor Narayan Rao introduces the next speaker, I want to place on record our special thanks to Dr. Alka Sharma, because Dr. Rajesh Gokhale, Secretary DBT, rang me up on Friday evening that he has met with a medical emergency and he cannot travel. So the only thing which I could think at that stage, that we have Alkaji with us who can speak equally well on this topic, and she is an accomplished scientist and science administration. But I came on this mic again to specially thank her for preparing her talk in a record time of 24 hours. Thank you, Alkaji.
Dr. Ravichandran, thank you very much for the exciting talk, motivating and inspiring the scientists, researchers, and students present here to align towards Deep Ocean Mission and blue economy. Many of the people, I'm sure, got excited with your talk regarding blue economy. The next eminent speaker is Dr. Alka Sharma. Dr. Alka Sharma is currently Senior Advisor in the Department of Biotechnology, DBT, of the Government of India. She is also the Managing Director of Biotechnology Industry Research Assistance Council, BIRAC, a public sector undertaking of DBT. She is dealing with research and policy issues in the emerging areas of biotechnology. She has made significant contributions in medtech innovations with the national and international partnerships, early and late translational research on various domain-specific areas of biotechnology. She has been instrumental in promoting and supporting public-private partnerships across the country, and also commercialization of indigenous and affordable technologies for a large number of patients in urban and rural settings. Her efforts have resulted in creation of several biotech startups, development of functional biomedical device prototypes, transfer of technologies, creation of a pool of medtech innovators in the country. She is actively involved in formulating legislation in biotech sector and headed the biosafety regulation division, including RCGM in DBT. She is the coordinator for management of COVID-19 related activities in DBT and BIRAC. She has received training at the Department of Microbiology and Infectious Diseases, NIH, US, for the management of extramural program. She has also received CSR Technology Award for innovation for her translational work. Now I have the pleasure of inviting Dr. Alka Sharma to give the talk.
Thank you, Dr. Rao, for your kind words. Namaskar, good afternoon, everyone. So, as PSA sir already said that the Secretary Department of Biotechnology, Dr. Rajesh S. Gokhale, could not come and here with us today because of unavoidable circumstances. On his behalf, sir, I am honored to cover the topic high performance manufacturing for a prosperous India. Yes, sir, it's biomanufacturing I am going to cover in my talk. So I will start with that as described by Paris Agreement. The climate change is a global emergency that goes beyond national borders. The current crisis of global climate change and depletion of non-renewable resources encourage us to find innovative solutions to mitigate climate change. So the roots of modern fossil-based manufacturing can be traced into the era of industrial revolution. The petrochemical derivatives comprise most of the chemical manufacturing sectors. And this, if you really see that given their non-renewable nature, rising oil prices, and of course climate crisis are motivating many countries to evaluate their reliance on petroleum-derived liquid fuels and petrochemicals. So now it's time to change and time to find an alternative routes of manufacturing and to have carbon negative means of manufacturing to meet our requirements for food, fuel, and so on. And the most importantly, these routes should be innovative, energy efficient, with reduced pollution. So this slide shows the mechanism cycle for innovative alternate manufacturing routes from innovation to technology, and this includes strengthening and aligning science and technology innovation ecosystem to promote and support innovation in the country, and also to have industrial policy compelling incentives for harnessing frontier technologies, workforce of desired skills, and appropriate regulatory reforms, and the last but very important, adequate budgetary allocation. So we at Department of Biotechnology aspire to drive eco-innovation by fostering biotech innovations and enterprises and strategically nurture and strengthen bioeconomy. So biomanufacturing is a new wave of manufacturing and which is high performance manufacturing for its versatility. This uses biological systems such as microbes, plant cells, and enzymes to produce commercially relevant products. This also covers replacement of fossil-derived chemicals and materials with renewable alternatives and locking atmospheric carbon in a stable forms. So we in India, we have paradoxical situation. India heavily imports carbon in the form of fossil stock, and at the same time a large quantity of carbonaceous resources is wasted in the form of agro residues, municipal solid waste, greenhouse gases. Therefore, enabling and incentivizing biomanufacturing to produce commercially important bio-based products is the game changer. And this is also aligned with our vision of our Honorable Prime Minister. He mentioned today in his address, he also emphasized this point, and it is aligned with that to achieve net zero carbon economy and also reducing emissions intensity of its GDP by 45% by 2030. So coming to Bio-E3 economic policy, this is the biotechnology for economy, environment, and ecology. And this is the initiative of Department of Biotechnology to have green, clean, and prosperous India. And this is aligned with this life for the environment, which our Honorable Prime Minister talked would be required. And this is for synthetic biology, gene editing, metabolic engineering, to develop novel microbial cell factories and designer enzymes for eventually replacing sugar feedstock-based fermentation with biomass or waste and bioresource-based fermentation for manufacturing of biogenic products. So biomanufacturing has potential to provide an alternative solution to the traditional petrochemical-based manufacturing and for the manufacturing of biogenic products such as food additives, pharmaceuticals, biogenic dyes, animal feed products, flavors and fragrances, bioplastics, biotextile, and this is the last but very, very important, agri-bioproducts. So the biomanufacturing will not only help in mitigating the challenge of climate change, but will also boost our bioeconomy and expand entrepreneurial ecosystem. So many of you may be aware that during last 8 years, our bioeconomy has grown 8 times, and in December 2021, it has crossed 80 billion US dollar. And this this data is being analyzed and knowing this soon. So India, owing to its rich bioresources, surplus biomass, sustainability, and also proven technological advances, is uniquely poised to become a successful biomanufacturing hub. And the target which we have to achieve by 2025 is 150 billion US dollar bioeconomy. So BIREC, which is an industry academia interface set up by Department of Biotechnology to promote and public-private partnership across the country in biotech sector. So BIREC-enabled biotech startups are already on the rise, and you can see the numbers here. They are promoting these startups through setting up incubation centers. Can be achieved faster and in a more meaningful manner when we have a women participation in the decision-making system at each stage and also at the leadership. So the vision of the prosperous India can be achieved faster with women empowerment. So Department of Biotechnology along BIREC, we have several activities and programs we have initiated for women entrepreneurs, and this is now a large number of women entrepreneurs in biotech sectors are across the country. And we also have the special program in Northeastern region, the hands-on training program for rural women. So I have privilege of sharing of the glimpses of an ambitious initiative taken jointly with Women Lift Health and Grand Challenge India. And this conference on women leading change in health and science was organized last month in Delhi, where we invited Miss Melinda Gates and similarly, as said by Ms. Melinda during this conference, when women are involved in decision-making process, the decisions are better for the society as a whole. So we, Department of Biotechnology, along with BioRec and other ministries and departments concerned, we are focusing on women empowerment and through various programs and schemes. So I wanted to highlight here because of the theme of the Science Congress. So I wanted to cover this also along with my biomanufacturing talk. So thank you very much.
Dr. Alka Sharma, thank you very much for the exciting talk. The next speaker is Dr. S. Chandrasekhar. Gifted with a keen analytical mind and backed by diligent hard work, Dr. Chandrasekhar made pioneering and outstanding contributions in diverse areas of many academies conferred fellowships on him. Dr. Chandrasekhar is a fellow of Indian Academy of Sciences, FASC, Indian National Academy of Science, FNA, and National Academy of Sciences, India, FNASC. His stellar research accomplishments drew the attention of scientific community and industrial sector, which resulted in recognitions, awards, and accolades. Infosys Prize 2014 for Physical Sciences, C.N.R. Rao National Prize in Chemical Research 2012, Goyal Prize in Chemical Sciences 2017, Reliance Platinum Jubilee Award, Ranbaxy Award in Pharmaceutical Sciences, and many more. As a crowning glory, Dr. Chandrasekhar was appointed as Secretary, Department of Science and Technology, DST, Government of India, to steer the science and technology program of the country, which empowers him to make India a leader in science and technology. Dr. Chandrasekhar, kindly deliver the talk.
Good afternoon, all of you, and greetings to the leadership sitting on the dais. Thank you, Professor Sood. Narayan Raoji, thank you for an elaborate introduction. While my predecessors, two secretaries, Ravi and Alka, attempted to share some slides on the topic given to them, I thought I'll go a little away from what was assigned to me. While we're talking of India and 2030, the S&T challenges and opportunities, I thought I'll touch upon my personal perspective and also what is the way forward is something I want to share with you. Also, I thought to keep the audience a little awake, I'm not using any slides. So either you could listen or relax. So you have two options now. Today we had a wonderful start to the 108th Science Congress. We all sincerely thank Honorable Prime Minister who has come online to greet all of us despite other commitments and also the recent sad at his family. He also gave us a direction on what is that India should be doing in the next 20 years. He has given us a clear direction on how we are going to progress on the quantum technologies, on the cyber security. Of course, we have taken the leadership of G20, where we also lead the global pharmacy in this country. We supply more than 50% of the APIs across the globe. So we already have decent manufacturing capacity, in the health sector, while we have to learn a bit on the innovation. Today's message also clearly gave us a direction that how grassroots can reach to global or global to grassroots. I think both ways it is possible. I'm happy that DST has one dedicated institute, National Innovation Foundation, which also has a stall in the exhibits now, showing how grassroots innovations can really reach the world. Similarly, the message from Honorable Prime Minister on how the research, what we do in the lab, reaches the land. But of course, we need to go back to the land and see what are the problems of the land that we can go back and work at the lab. To have a concrete plan for our future 2030, I also thought it is good to recollect what has been the history. Unless we know the history and the mistakes we have done in the past, we will not be able to correct those mistakes and do better than what we have done yesterday. No one would complain that scientists or technologists have done bad. Since the industrial revolutions, whatever was a shortage, we made sure that those shortages are fulfilled with overproduction. N number of examples, including the green revolution, including the white revolution, the blue revolution, whatever revolutions we have thought of, including the Y2K, which some of the youngsters in the backbenchers might have not seen, but the panic all of us have undergone in the year 1999 has been overcome with the commitments of researchers across the world, and of course, India has played a very important role. So history has been great, but when we look back at the technologies we have developed, they were essential. We required those technologies on a fast track, and in the process, we ignored a lot of environmental factors. Industry started learning the E factor only much later after we made some mistakes. Today, when talking of Industry 4.0 and many other things to see how our manufacturing sector could lead the next generation manufacturing. When you look at the literature, how a factory was looking in the early 1900 and how the factory looks in 2000 and how a factory will look at 2030 has to be imagined by the scientific community and make our science which fit those future factories. I can assure you that those factories will not look like the kind of factories we see today, the long chimneys occupying acres of land. Once we get into continuous manufacturing, they would be as compact as this hall, and maybe this will produce tons and tons of product to take care of one ailment or one agricultural requirement. So the need of the Science Congress, where large conglomerate of scientific fraternity assemble here, it's the time for all of us to think what is that India or the globe needs in 2035 and whether my lab is doing that work or not. I think that's the decision we have to take when we give a PhD problem to our own students, or when we choose a research problem to write a proposal to any of the funding agencies, including DBT or DST or CSIR. Are we doing this exercise that my science is going to be translatable by 2030? Again, Honorable Prime Minister today has emphatically mentioned today, unless the science what we do in the lab reaches either the market or the people who want to use it, I think this science will remain in the journals forever, while we can keep building the fundamental science parallelly. When we look at the challenges we encountered while we were doing these industrial revolutions, as I mentioned, while E factor was one of the largest factors, many industries today suffered challenges from Pollution Control Board. Also, they find a lot of challenges when you want to measure the amount of carbon you put into your reaction and what is the carbon you are getting out of the process. It's the time for all of us to design our science in such a way that the input and the output has to be perfectly matching. When I put 1 unit of energy or 1 unit of raw material I should be able to get back my 1 unit of product and 1 unit of energy has to go for recycle. Our science has to be circular, like we talk of circular economy, and I do believe that the Science Congress would debate more on how this circularity of science and technology will make this planet a livable one. The title of this session has a keyword, sustainability, which Ravi and Alka also have touched upon. If you go and look at the Oxford Dictionary, the definition of sustainability could be manifold. But for me, the definition of sustainability is what I have borrowed from my grandparents, am I handing over to my next generation, my grandson, in a better form, or am I spoiling it and giving it? On a personal front, we are all excited that if my grandfather has given me X assets, I'll try to multiply 100 X assets and try to give to my grandchild. But am I going back to consider that my grandfather was consuming the amount of carbon he was consuming versus the amount of carbon I am consuming today? Am I going to teach my grandson, can you use the same carbon what my grandfather has used, but with equal materialistic comfort what we are enjoying today? I think these challenges, unless we post our own researchers in the research labs, I know we are all researchers, I don't see many industry friends here, but unless this grassroots thought process in our own labs begin, we are not going to give solutions to the industry. So I urge on this platform, several vice chancellors are sitting in this audience, to please consider choosing the problems which are relevant for 2030. I also would like to say that when we looked at the revolutions of agriculture, we always look back and look at Swaminathan. We also look at Korean for White Revolution. But then when we really look at the amount of urea, pesticides we started consuming at that time, whether our agricultural research, while the hybridization of seed varieties or the eco-friendly pesticides, which will not harm the farmer who's spraying those chemicals, or the chemicals which use the chlorofluorocarbons and refrigeration, which are going to damage the ozone, and the ozone depletion happens, the global warming happens, and Ravi did not touch upon, but the way the Arctic, Antarctic, Himalayan belts are melting, the way our sea levels are increasing, everything is interconnected, and those challenges have to be addressed in the laboratory on the research what we do today. So when we talk of this green revolution, we also know that the amount of urea we consume per farmer, I am told by the agricultural friends that we buy urea of a 45 kg bag at about 3,500 rupees. But farmer cannot afford to buy this urea at that price if he has to give you 35 rupees a kilo of the rice what you buy in the market. So government has to give a subsidy of almost 90% so that the farmer pays only 1/5 or 1/10 of the price so that he can make an affordable agriculture. But can we make a technology of urea so great that government need not give subsidy, but still this could be sold at the affordable price what my farmer needs it? When you look back at the urea, we need a lot of ammonia. Whether do we have a green ammonia process in this country? Can India will become self-sufficient on green ammonia by 2030, enough urea at the cost what a farmer can afford? While we're talking of urea, it's also not so pleasant to hear those who drive a Euro 6.0 diesel car. Unfortunately, they consume 99.99% ultra-pure urea in their diesel engines to avoid the nitric oxide gases which are coming out. So are we competing with the farmer to take his urea in the process of emitting less emissions from our diesel vehicle? So have we thought of whether I could make any other chemical which can replace urea so that I will not compete with the farmer? Or can I have an engine which will not produce so much of nitric oxide from my diesel engine so that I get the ultra-pure diesel, that this load is not there on the urea? I think these are the questions we need to ask ourselves before we embark onto our research problems. While we talk of sustainability, as I mentioned, what is that we borrowed from yesterday and what is that I'm giving it to my next generation tomorrow? We have talked of net zero. I am borrowing the fossil fuel carbon from the mother nature, and I give back to the mother nature carbon dioxide. Mother gave you a stable carbon to us, and we make carbon dioxide, which is not so good. This planet also gives us nitrogen. We consume it and give it back in the form of nitric oxide, which is not good for the environment again. So we always oxidize what is given to us and give it back. So what is that? We complete a cyclic loop that while I do an oxidation process for my effective use of these metals or minerals or whatever I get from the earth crust or from the ocean, what Ravi has spoken, can I complete the cycle in a proper redox process that again I'll recycle what I have produced? I think these are the questions we need to pose. Unless we ask these questions, our science will not be relevant for 2030. One major challenge what we encounter in science today is all my scientists who are sitting in the audience keep complaining that my first student was the best student, but I'm not getting as the good students I got 30 years ago. But are we giving the same kind of personal touch to those students what 30 years ago we were giving? So we need to again complete for sustainable research in our labs. We need the best quality students. Again, those have to come from the state universities. I'm sure again, many faculty sitting in this audience, including the vice chancellors. What are those reforms they are doing that they are going to supply the best input of students for my science programs, that my output of science is also as expected by the nation. So for sustainable research, we also need sustainable students. A student who can sustain all the pressure and all the stress and survive in the lab as long as he can deliver the goods. Honorable Prime Minister also has given a call on lifestyle for environment, which he touched upon today. And I also saw on Alka one of the slides on life. Again, I think if we change our lifestyle, starting from how we take our bath in the morning, till evening when we shut down our doors and turn on our mosquito repellent, which has some impact on the environment, how are we going to address every bit of our morning, 6 a.m. to 10 p.m., whatever we do, whether we could change our lifestyle, that the burden on the environment comes down. DST has taken many initiatives on how we could really fund the state university researchers in such a way that they give the early training to those young students, that when they reach the national institutes, including IITs and ISC, that they really work to the expectation of those faculty. The program that we started recently, which is the State University Research Excellence, which has got excellent traction. We're also building capacity on many equipment. We're also building the clusters under Sathi program, where all researchers can go and use the facilities what are created for common good. I think these are some measures which DST is taking in partnership with ACRB. TDB supports many programs of hand-holding these startups in such a way that they develop the future technologies. While we talk of sustainability, I also would like to urge my friends that don't confine to be an extreme specialized scientist, and we can always go back and look at the medical fraternity. If you are suffering from a small ailment, and if you go to an extremely super specialist, he would not be able to know what is happening. We also need scientists who are working at the interfaces so that they can connect the missing dots, and our interdisciplinary science can bring in sustainable solutions. Another initiative which DST has taken is to see how women also participate in the scientific programs. While, again, we are proud that CSR DG is women, and then she is leading from the front the entire scientific department. We also would like to make sure that the programs which are built by DST under Kiran program will cater to all the girls from age group of 17 to the age group of 65. Those who also have to sacrifice for family reasons, a break in their career, who take up these programs, that equal participation of women in our scientific activities happen. While I might be out of time, I only would like to urge all my friends sitting here is that when we take up our problems for our research in the laboratory, please make sure that those problems are also addressing the sustainability. Those programs also address the needs of 2030 and 2040, and also make sure that we become the world leaders by 2047 on the cutting edge science, what we continue to do. On behalf of DST again, I invite the friends sitting here to see that they visit our website frequently, to see the kind of new calls we give, the kind of new programs we launch, that we get a very competitive participation from all of you. Thank you. Jai Hind.
Dr. Chandrasekhar, thank you very much for kindly elaborating the challenges and opportunities and also describing the new initiatives of DST which will definitely benefit many of the scientists and academicians present in the audience. The next eminent speaker is Dr. Kalai Selvi. Dr. Kalai Selvi assumed charge as Secretary, Department of Scientific and Industrial Research, DSIR, and Director General, Council of Scientific and Industrial Research, CSIR, on 8th August 2022. Dr. Kalai Selvi is the first woman Director General of CSIR. Madam General President, please give a clap. Sustainable development through women empowerment. So she is the first woman Director General of CSIR. Prior to taking over as Secretary, DSIR and DG CSIR, Dr. Kalai Selvi was Director of the well-known CSIR, Central Electrochemical Research Institute, SECRI, Karaikudi. Dr. Kalai Selvi's research work of more than 25 years is primarily focused on electrochemicals, power systems, and in particular, development of electrode materials for energy storage devices. Her research interests include lithium-ion batteries and beyond, sodium-ion and several others, supercapacitors and waste-to-wealth driven electrodes and electrolytes for energy storage applications. Dr. Kalai Selvi was instrumental and coordinated the preparation of technical report on National Mission for Electric Mobility. Dr. Kalai Selvi has more than 150 publications and 6 patents to her credit. Under her guidance, 12 students obtained their PhD degrees, and presently a couple of students are pursuing their doctoral programs. She is a recipient of many prestigious awards, including MRSI Medal, CSIR Raman Research Fellowship, INSA NRF Exchange Award, Brain Pool Fellowship of Korea, the Most Inspiring Woman Scientist Award, and C.V. Raman Mahila Vignana Puraskara at 12th National Women Science Congress held at Mysore. Now, it's my privilege and pleasure to invite Dr. Kalai Selvi to present.
Namaskar, Vanakkam, good evening, Indian Science Congress. Thank you very much for the nice introduction. Of course, I was not in favor of this introductory part. Thank you anyway. Friends, I will just take half a minute to just think about this 108 as a number. Whenever we say something for only one time, it is the order or it is by order. When you say something 2 times, you should be a teacher. Because first you say something, then you want to confirm whether you really reached. Therefore, you say anything for 2 times. If you say something 3 times, then definitely you are a strong believer of law or court of justice. And if you are saying the same thing for more than 3 times, you should be a parent. You will be going on repeating one same point to your children. But if something is told 108 times, I think normally we correlate it with prayers Or normally we say that I want to achieve it by somehow or other. I'm so adamant, this is my prayer, this is my commitment, and at any cost I want it means we will be going on chanting it as mantra is really, really picking up extra importance. And all the 107 times whatever we discussed along with this time, we will definitely make India to feel proud about it. And with all these outcomes, I'm confident that India will be positioned very much at the top of the position in the global scenario. So now, let's take some time to think about if we want to position India in the global scenario, not as a participatory nation, but as a leading nation, what are the essential challenges which are just lying ahead, and how to encash them and how to make them as opportunities. This is where I'll be just talking with you for next 10 minutes or so, or 15 minutes. As all of you know, I'm from CSIR family. CSIR is another big family, 37 national labs and 39 extension centers, number of center of excellences, and 15,000 plus research scholars, several thousands of scientists, researchers, students, scholars, and my family is a big family, as big as India. And therefore, if you just want to know what this CSIR is doing in the field of science and technology, please visit our CSIR pavilion. And one great and the pride of CSIR is the only organization wherein the president of CSIR, or I would say the leader of science, is the same leader of this nation. Yes, Honorable Prime Minister is the president of CSIR, and that is where we take extra commitment, extra responsibility, and extra ownership that the country's science touch upon. What is it that we have to do from 2023 to 2030? Because topic of today is 2030. Therefore, we are left with one number called 7. 7 is a great number again, because 7 days a week, 7 colors in Vibgr. And today only I came to know when Dr. Ravichandran presented the draft policy, blue economy policy. There also they are coming up with 7 important points. And 7 colors in the rainbow, I told you. There are 7 continents, 7 wonders of the world, 7 habits of the highly effective people. And it is such a great coincidence. Of the 17 SDGs, the 7th Sustainable Development Goal is affordable and clean energy. Therefore, this is high time that we should think about what is to be done in the next 7 years. And again, if you just think about January, it is the month which is named after the Roman god Janus. And we strongly believe he is the protector of gates as well as the doorways, who is capable of looking into the past and who can really think about the future also. And therefore, it is really, really worth and best fit to plan anything and everything in the month of January. That's why in the month of January, every time we are celebrating Indian Science Congress. And friends, now coming to what is it that, because I told that Janus is capable of thinking about the past, look into the past, and to look into the future. So what is it that we have done? In the past years, this country has come up with the Technology Vision 2035. Before I go to the next point, I think I just want to make this as an appeal from my end. When we are talking about Indian Science Congress, how many of us have really gone through the address of the Honorable Prime Minister of this nation in very many Indian Science Congress? If you have not gone through, I strongly, strongly advise, recommend, and suggest, please, today itself, go Google and just download and read what the Honorable Prime Minister of India has talked in the past Indian Science Congress also. Then you will really feel like committed, like you have to do something for this nation. That much spirit is there in the talk. That much spirit is there in the content, and therefore, please take this as a great homework today. So now coming to the glimpses of the past, as I told you, so the country has already decided and we have designed the technology vision 2035, deep ocean mission. My good friend was also talking about it, and cyber physical systems. This is high time we have to think very seriously about the cyber physical system, innovations and startups. Once upon a time, I would say, or just one decade before, it was a rarely thought about thing. But now startup is a fancy word. So once upon a time, even today morning also I was telling, women means we were just identified as self-help groups. Now we are coming up with women startup. Therefore, startup has created a new culture in the thought process, new culture in our working principles, new culture in our way of functioning also. And if you just talk about the work culture, many a times, even in the past, it has been reiterated, we have to break down the silos and we have to come up with a partnership. The Honorable Minister of Science and Technology, today morning also, he was insisting upon public-private partnership. How many times we are thinking very effectively on this point? Friends, let us start thinking very loudly, at least from now onwards, at least from this Science Congress onwards. Next one is how best schools and students are getting themselves connected with the students. My another good friend, Dr. Chandrasekhar, was talking about how we have to think about sustainability and carbon credits starting from grandfather to grandchildren. Now, the Honorable Prime Minister, in one of the earlier meetings with CSIR, he raised this very important point. He asked us, on the face, he asked us, you as scientists, how many of you are making sure that you are getting very much connected to the students of this country so that you are making the second line leaders in the field of science and technology? That is the time where CSIR started thinking very seriously. We are now coming up with, we have some program called Jigyasa, skill development program. Through all these programs, all the scientists of CSIR labs are getting connected with the school children as well as college students. And the last one, as all of you know, waste to wealth. Number of ideas and number of opportunities are there to implement waste to wealth. So whatever is converted from the waste to wealth, even morning also, the Honorable Minister Nitin Gadkari ji was also talking about waste to wealth. And every time, whenever we are making waste to wealth, one example I will tell you, if you are taking the cooked oil, reused oil, cooked oil, that could be converted into a biojet fuel, by means of which you are not only making the waste into wealth, but also you are ensuring health. Because oil reusage is not good for health. Therefore, the moment you are making it as a movement, the moment you are making it as a great awareness to all the Indian women folk that the cooked oil should be again sold out, by means of which they can really ensure good health, also wealth. So this is how this waste to wealth also should be thought about from different perspectives. And also from CSIR, we are coming up with Atal Innovation Mission. Again, big thanks to Niti Aayog and other teams. Sustainable startups, because we are not happy by telling only startup, the startup should be sustainable. Anything and everything to be successful, sustainability is the tag word. So that is why even in this focal theme of this Congress, we have talked about sustainability. And I'm extremely happy when you chose this sustainability for science and technology, you have rightly tagged that sustainable development with women empowerment. My special thanks are due to the organizers. And the next one is top space-faring nation, TB-free India, ease of doing science, COVID-19 mitigation, India's nasal vaccine. These are all the very, very great points, or the good points that we talked about. Now, what is it that we can do in the next 7 years, up to 2030? So as I already told you, these are the sustainable development goals. Depending upon the area in which you and me, we are working, We can choose, we can adopt, we can take the ownership of one sustainable development goal, and we have to dedicate our lifetime research in that sustainable development goal. If all of us make up our mind in that direction, I think sustainable development goals will definitely have a lot of impact in real-time application. So if you just take India's sustainable goal, so India is critical in determining the success of sustainable development goals, because if you just take whatever be the national mission that is already launched or which is getting launched or which is in the pipeline, everywhere we are prioritizing a minimum of 1 or 2 sustainable development goals. For example, if you even take the case of Deep Ocean Mission or Hydrogen Mission, for that matter, Green Hydrogen Mission, I think Green Hydrogen Mission is a great initiative. Morning also, Honorable Prime Minister made a mention. Friends, CSIR has already taken initiative. We have launched our Green Hydrogen Mission and we started working towards that. And it is pan-CSIR wherein industries are also involved. And now country is going to come up with a much more bigger pan-India green hydrogen mission through an international conference, which is again getting mentored by our Honorable PSA, Dr. Ajay Soodji, who is sitting here. And I think we are getting ourselves geared up in all possible ways. India is trying its level best to fulfill the sustainable development goals. And all our activities in one form or other, we are getting ourselves correlated and aligned with the sustainable development goals. And we from CSIR, as I already told, having the Honorable Prime Minister on board as President, whatever announcements are being made as Government of India policy or scheme or announcement by this government, immediately it becomes the responsibility of CSIR to give a scientific shape. The moment we give a scientific shape, we do realize and we do understand that through science, I cannot touch upon the common man for his every requirement. The science has to be converted into technology. This is where we are joining hands with industry. The moment it is converted into technology, then also I cannot directly touch upon the life of the common man, because common man is having his reach only up to market. Therefore, again, this technology has to be made as a market acceptable product or market acceptable device. So with the help of industries, we from CSIR Labs, we just make it as our commitment that we should reach the market, because common man is having reach only up to the market. Therefore, the moment our products reach market, we have the feeling that, yes, CSIR is touching the lives of Indian citizens. So this is where our activities are also mapping. I will just showcase 7 important cases. I will not go through the details. If you just take the case of healthcare, so these are the challenges. Because I said that I will just tell you what are the challenges and what are the opportunities. So carefully just go through the bullets. Every bullet will talk about a challenge, and the next slide I will talk about how you can make it as an opportunity also. So the challenges with respect to healthcare is, one is, can you make it as an affordable healthcare at this point of time? One challenge. Preventive healthcare, another thing. Early detection and diagnosis, this is the third one. Pandemics and endemics, fourth one. Rural-urban disparity, this is the fifth one. And the last one is sickle cell anemia, which is pertinent to one set of group of people in this country. The same challenges could definitely be made as opportunities, because we have number of learnings from COVID-19. Now this country, especially from CSIR, we have come up with a mRNA vaccine platform. It is an indigenized platform. Now we can even think about how best we can help ourselves and how much we can say that we are prepared to mitigate the future pandemics also. So this much learning we got from COVID. So pandemic and endemic preparedness, it is very much initiated, but we have to strengthen it. Leveraging digital technologies, personalized wellness solutions, integrating traditional medical systems. CSIR is working very closely with the Ministry of Ayush, and we are coming up with the traditional knowledge digital library also. We call it as TKDL, wherein we are giving a lot of importance to healthcare. Now we will be soon expanding it to agri as well as materials and minerals. So if you just take the second challenge, which is environment and climate challenge. So here the challenges, as all of you are aware, water security, air pollution, waste management, smart agriculture, because Honorable Prime Minister is all the time telling that the farmer's income should be doubled, and therefore it should be done only with technology, therefore smart agriculture, and the last one is biodiversity. How to meet out all these challenges and how to make them as opportunities? So one is Heliborn survey. CSIR is having a Heliborn survey, by means of which you can really map underground water. So we call it as water mapping. Water mapping in water arid areas also we have completed, and we have plans for another 5 states in the near future for water mapping and management. Rejuvenation of water bodies, we are coming up with a number of technologies. Waste to wealth, already I shared one example. I have number of examples. Instead of listening to me, you can visit the CSIR pavilion. There you will have number of interesting stories on it. Soil health. Actually, the PSA sir was talking about this one health, or he was talking about human health, animal health, and he was talking about wild health. From CSIR, we have included even plant health and soil health also under the umbrella of One Health. So soil health also we started bothering and we started working towards, and community participation platforms and predictive analysis and the impacts of climate change. Now the third one is energy and mobility. So 30 million people even today are really suffering without sufficient amount of power. That is the data, real-time data. Transmission and distribution losses are becoming unavoidable even today, even after this much of science and technology. Coal is abundantly available in the country. Mother Nature has blessed us abundantly with a lot of resources that includes even coal. But how to make this coal as clean coal, that is where the challenge lies. And how best this coal could be converted into hydrogen, that is another challenge. Then oil, it is vehicular consumption. Fortunately or unfortunately, we are not having those many oil wells. Actually, if at all, necessity is the mother of invention. Therefore, scarcity of oil is a challenge that will give us new lessons. And renewables, we have to scale up the challenges. So when you come to opportunities, hydrogen and renewable energy, I already told you, Pan-India missions and PLI scheme of Government of India is another opportunity. Lithium-ion batteries, redox flow batteries, hybrid systems, supercapacitors, all these are opportunities. Private sector is nowadays showing interest. Their participation is another opportunity. Clean energy and biojet fuel. I already narrated biojet fuel story. And the last one is incubation centers. We are coming up with a number of incubation centers. Now NRDC is also getting themselves geared up to increase the incubation centers, and soon we will be coming up with more number of incubation centers. Food and nutrition, friends, this is the year of millets. Fortunately, CSIR is having one institute called CSIR Central Food Research Technology Institute at Mysuru. So here the challenges are malnutrition, overnutrition and non-communicable diseases, food accessibility and affordability, climate change, balanced diet related awareness. Therefore, opportunities, under opportunities, this is the year where we can address all those issues. Nutraceuticals and fortified foods, we are working on it. Traditional foods, we will be soon coming up with a kind of a list of traditional foods with their value also, food calorific value and nutritional value also. Enriched crops and Samba Masuri rice. The Samba Masuri rice is again a diabetic-free rice or diabetic-resistant rice that we are coming up with. We are working so closely with ICAR also, Indian Council of Agricultural Research. And the last one, as I said, soon we'll be coming up with the catalog with indigenous food. Everywhere indigenization is very important, so we will talk about only indigenous food in that catalog. And the fifth one is Industry 4.0 and 5.0. So the problems, the challenges, I could say that it is an innovation culture, AI, robotics, 3D printing, They are not at all familiar at the school level, because if you just see our nearest neighbor, China, at school level, they started teaching all these technologies and all these fundamentals to the children, but we have not yet started skill development and cyber security. But coming to opportunities, you have Skill India program. You can strengthen your IP portfolio. Meaning is every patent should be valorized, every patent should be commercialized. Indigenous technologies and smart devices should be other opportunity. We have to go for increased customization. COVID really taught us number of lessons. All the existing technologies, we tried our level best to repurpose them. This is how customization should be done. And startups, I already told, we have to make it as an opportunity. And the sixth one is, this is very much close to heart to our Honorable Prime Minister and Minister of Science and Technology. Both of them, they all the time talk about ease of doing science. Ease of doing science, again, challenges doing science at par with global standards. Whatever we do should be accepted globally. Equitable access to scientific information, lack of guidelines, working in silos, research administration. Main thing is supply chain management. Whatever we talk about indigenization, do we have the supply chain in place today? The answer is no. We have to make the supply chain from end to end. Only then we can talk about indigenization, Atmanirbhar Bharat, and self-reliant India. Only one more point. So opportunity is again ease of doing science index, one nation, one subscription, iSTEM, extramural grant, strengthening partnership, research facilitation, as I told, indigenization and Atmanirbhar Bharat. So these are the opportunities. And the last point is very important, attracting and retaining the talent in India. That is much more important. In schools, actually the challenge is we have to come up with the instilling interest in science, higher education, less challenging career options. In research infrastructure and other limitations are still prevailing to some extent. Non-uniformity in many ages, retirement ages and other policy-related things. Then competing private and global opportunities are the challenges. Coming to opportunities, Atal Tinkering Lab could be properly utilized. Programs like Inspire, CPYLS, Jigyasa, these are all the programs which could be effectively utilized by our youngsters. Special initiatives for women researchers. This year from CSIR also we are coming up with a dedicated call, special drive for women researchers for submission of project proposals. Please make use of that opportunity. Soon we'll come up with a kind of a call, and it is exclusively for only women researchers. And CSIR labs, we will be finding our participation in institutes, academic institutes and industry. Science festivals and outreach could also be used as the opportunity. So next 7 years, it is an exciting period. So I'm really excited what is going to happen in next 7 years. It is not only the excitation, it is not only related to emotion. We have to put in all our efforts and hard work. Only then we will come up with exciting results. Science and technology can immensely contribute. We have to tell this to ourselves every day. Lay the foundation stone for these 17 years from 2023 to 2047, because country is all the more geared up for India at 2047. So whatever we are planning now, first we can have one step as 2030. From 2030, we have to think about, it should be leveraged to 2047. And the last one is a developed India in 2047, because India is now a developing country. At least in 2047, it should be a developed country. Thank you very much.
Dr. Kalai Selvi, thank you very much for the exciting talk with energy. I'm sure you made all the audience alert and listen to you. Thank you so much. Now I request Chairman of the session, Professor Ajay Kumar Sood, PSA to the Government of India, to give concluding remarks. After that, we have very important function. I request all the members present here to be present here for another 20 minutes. We have a very important function after this.
No, I will not take more time, but just to say it was a very exciting session. And I would like to thank all the speakers who did a marvelous job and wonderful audience who listened them so very nicely. Thank you.
I have immense pleasure in inviting the General President of the Indian Science Congress Association, Dr. Vijayalakshmi Saxena, to conduct Ashutosh Mukherjee Award ceremony bestowed on Professor Ajay Kumar Sood. After this memento.
It is a great honor and pride for me and all for the Indian Science Congress that the medal, Ashutosh Mukherjee Medal, is going to be conferred to Professor Sood. This hearty congratulations to you, sir, for this award. This award was instituted in the name of Professor Ashutosh Mukherjee, who was the General President, first General President of the Indian Science Congress, and it was instituted during the Platinum Jubilee year of Indian Science Congress in the year 1988. So I'm overwhelmed to confer this award to Professor Sood. Yes.
As a token of appreciation for chairing the session and also the distinguished speakers who have delivered the talks, Indian Science Congress Association would like to present mementos to all the distinguished speakers present here. I request the Vice Chancellor, RTM Nagpur University, and also the General President Vijayalakshmi Saxena to present mementos to our distinguished speakers. First, I request the Vice Chancellor to present the memento to the Chairman of the session, Professor Ajay Kumar Sood. Give a big clap. Yeah. Now I invite Dr. Ravichandran, Secretary Minister of Earth Sciences, to kindly accept the memento from the Indian Science Congress Association. It's my pleasure to invite Dr. Alka Sharma of DBT. Now it's my great privilege and honor to invite Dr. Chandrasekhar, Secretary DST, to kindly accept the memento. Now my privilege to invite the first woman Director General of CSIR to accept the memento.
And I request Honorable Vice Chancellor to please felicitate convener Dr. Narayan Rao as he is behind to coordinating this event. Thank you, sir. Thank you, ma'am. Now for the plenary session, I just review. This year, Indian Science Congress 108 have received 120 total abstract for the plenary session. So there are total 120 plenary session, actually 27 plenary session with 120 talk is going on in next 5 days. So all are requested to take enjoy of all this plenary session feast. And now it is a last juncture of this program. Actually, I am very small to express the thanks to all these dignitaries, as these are the peoples which are eminent in their field and they have shown extra talent in their field with their research contribution. So my words are very small, but I take an opportunity to express my deep gratitude towards Professor Ajay Sood, Dr. Chandrasekhar, Dr. M. Ravichandran, Dr. Kala Salve ma'am, Dr. Alka Sharma ma'am for their valuable contribution in ISC 108 by inaugurating the plenary session and giving a very valuable guidance and showing us a future opportunities for R&D as well as whatever the challenge we are facing. So again in last, we should have to give a big round of applause to just say a thanks to them. Okay. Then I express my thanks to Dr. Narayan Rao for coordinating all this event, okay, to make this event successful, for bringing these laureates in this platform, same platform. Then I thanks to ISCA for giving an opportunity to RTM Nagpur University for organizing ISC 108 in RTMNU campus. And all the delegates, I want to express my deep thanks because their presence have made this event more successful, because if the plenary session first is successful, it means that the whole plenary session becomes successful. So thank you very much for coming and making this event successful. Okay. Okay, unveil here. Sorry, one event is remained, that is unveiling of souvenir of abstract book, as we have received 120 abstract. So now I request the Narayan Rao and our whole secretariat as well as the Ajay Sood sir to please unveil the abstract book. Now again I want to say that in this total abstract there are 32 contributions from outside the India out of 120 total abstract. And there are representation from USA, Australia, Japan, Singapore, Malaysia.
As I said in the beginning, this is a unique occasion to have that many secretaries on the same platform and the dais. To commemorate this unique feature, let's give a standing ovation to these distinguished scientists of this country.
Just media launch. Just opposite exhibition, that media launch is there.
Yeah, I think your plenary lecture is there. Yeah.